Welcome back to another episode of Cosmic Chronicles, where we explore the wonders of the universe and unravel the mysteries of space. Today, we have an incredible story that stretches the imagination and takes us billions of years back in time. So, buckle up as we dive into the fascinating discovery of a quasar that has astronomers buzzing with excitement. Imagine a celestial object so distant that its light takes over 12 billion years to reach us. In a recent groundbreaking discovery, two teams of astronomers have identified the largest, most distant reservoir of water ever observed in the cosmos, located in a quasar known as APM 08279 255. This remarkable quasar, which is an active galaxy powered by a supermassive black hole, is estimated to contain about 140 trillion times the amount of water found in all of Earth's oceans. Yes, you heard that right, 140 trillion times. To put this into perspective, APM 08279 255 is not just a speck in the vast universe, it's a beacon of light from a time when galaxies and black holes were still in their infancy. With a measured redshift of approximately 3.87, we are witnessing this quasar as it looked more than 10 billion years ago. The brightness of this distant object is noteworthy, shining brightly in both visible light and far infrared wavelengths, suggesting that multiple physical processes are at play to amplify its light. Matt Bradford, a scientist at NASA's Jet Propulsion Laboratory, is one of the leading researchers behind this discovery. He emphasizes the uniqueness of the environment surrounding this quasar, stating, "It's another demonstration that water is pervasive throughout the universe, even at the very earliest times." This finding not only showcases the presence of water in the early universe, but also opens up new avenues for understanding the evolution of galaxies. Bradford's team, working alongside another group led by Darius Liss at Caltech, utilized cutting-edge technology to detect the water in APM 08279 5255. They employed the Plateau de Bure interferometer, located in the French Alps, to spot the water through a single spectral signature. Their findings were later complemented by Bradford's team, who detected multiple water lines, revealing the immense mass of the water cloud surrounding the quasar. Now you might wonder, how do astronomers make sense of such distant objects? The answer lies in the phenomenon known as redshift. As the universe expands, light traveling through space stretches, shifting toward redder colors. This redshift allows astronomers to gauge how far away an object is and provides a glimpse into the past. In this case, the redshift near 3.9 places APM 08279 5255 firmly in the early universe, enabling scientists to estimate a look-back time of over 10 billion years. What makes this quasar even more intriguing is its classification as a broad absorption line quasar, or BAL quasar for short. This means that its spectrum exhibits wide dips, indicative of fast winds racing outward from the black hole's central region. These winds absorb some of the light behind them and give astronomers insight into the feedback mechanisms at play. The interaction between water vapor and material falling into the black hole can also create powerful winds that influence star formation and the evolution of the host galaxy. Initial estimates of the quasar's luminosity, its total power output across all wavelengths, are staggering, hovering around several quadrillion times the luminosity of our Sun. Such incredible numbers raise questions. Is the quasar genuinely that powerful, or is something along the line of sight amplifying its brightness? To address this, astronomers consider gravitational lensing, a phenomenon where massive objects bend the fabric of space-time, magnifying background sources. In the case of APM 08279 5255, images reveal that the quasar isn't perfectly point-like. It appears slightly elongated, suggesting the influence of a foreground galaxy. A basic lensing model indicates that the optical light from the quasar could be magnified by a factor of about 40. Even after accounting for this gravitational lensing, the quasar still possesses an astonishing intrinsic power, estimated at around 100 trillion suns. Brightness alone doesn't provide the full story, though. Astronomers compare the quasar's light across various wavelengths to understand its nature better. The spectral energy distribution shows strong emissions in both far infrared and optical wavelengths, indicating a dust-rich environment. This dust near the active nucleus absorbs energetic radiation and re-emits it at longer wavelengths, further illuminating the complexity of this cosmic structure. The researchers also noted that APM 08279 Pli5255 exhibits traits typical of BAL quasars, such as being radio quiet with only minimal radio emissions and a lack of strong X-rays. These characteristics reinforce its classification within the BAL family. The implications of this discovery extend beyond just one quasar. It encourages astronomers to rethink existing astronomical catalogs. The IRAS faint source catalog is vast, and many entries may not have received thorough spectroscopic follow-up. If APM 08279 5255, along with a handful of other extreme sources, turns out to be lensed, it could indicate that there are more hidden, distant, dust-rich, hyperluminous galaxies waiting to be discovered. Gravitational lensing acts like a natural telescope, enhancing our sensitivity and revealing details that would otherwise remain obscured at high redshifts. By cross-referencing optical, infrared, and radio surveys, astronomers have opportunities to uncover more cases like this and refine our understanding of black hole growth, dust heating, and galaxy assembly in the universe's early days. As we conclude this exploration of APM 08279 Pli5255, we are left in awe of the immense scale and complexity of the cosmos. The measurements of water vapor and other molecules suggest that there's enough gas for the black hole to grow to about 6 times its current size. However, the outcome isn't guaranteed. Gas may condense into new stars or get blown away from the quasar altogether. This ongoing pursuit of knowledge reveals just how interconnected the universe is, where every new finding provides another glimpse into the grand narrative of cosmic evolution. Each discovery brings us closer to understanding the fundamental processes that shaped galaxies and black holes when the universe was just a few billion years old. Thanks for joining us on this journey through the cosmos. Until next time, keep looking up at the stars and pondering the mysteries they hold.